Hi and welcome. In this Houdini tutorial, I would like to share with you a brief overview regarding rest position and inverse transformation. We will explore this topic creating 3 practical examples. I hope you find it interesting. Let's start. Okay, so here we are in Houdini and we have this animation from Mixamo. This is the same that I use also in the preview shot. So the plan is that we want to cut the geometry and pass it through an RBD simulation. To cut it is always best that the object, the animation is still, and is in the wall space origin, so in 0, 0. So how we can do that? Let's start with copying this animation in another geometry container, and we can call it rest position. Object merge. So if we check the attributes, we have position, normals, and UV. We don't have a rest position, so this means that we have to create it. One way to create it is, for example, to time shift it, delete this channel, first frame, and transform it. We want to transform his centroid back to the origin, and the way to do it is by negating his centroid. And here it is, resting in the origin. Then we can use a node called rest position, who will create the rest attribute for us. So now we have position and rest. Okay, that good. We have to store also the animation, because we plan it to move it and then to cut it and then reapply the animation. And we can store that information. We're using an attribute wrangle. Let's call it attribute animation. And we can say that v at animation is equal to position. Let's give it a color. So we have now 2 more attributes that we didn't have before: animation, rest, and okay, we had the position. So let's bring it to the origin, and we can do it with another attribute wrangle, and say go to rest. The position is equal to rest, and it snaps there. If we check, we see that is time dependent. We don't want that. In the rest, we want it to be not moving. So another time shift. Delete this channel first. Okay. So now we can create an ISO offset to give it some resolution, and this scatter some points. 20 again, and we can Voronoi fracture it. So we can fracture this geometry with these points. Okay, so this is done. But now we want to use this cutted geometry with this animation. So we can use for that another wrangle, and we want to transform this animation with this data. So first of all, we can import it. So we create a vector, anim is equal to point. The attribute is animation, and add ptnum. So now we just say that position is equal to anim. And it's not working. It's not working for a simple reason that the point number is not the same. We have here 13,000 points, and after we Voronoi fracture it, we have 15,000. So this is a guessing. The proper way to do that is creating a transformation matrix, and we are going to do it next. Okay, first things first, let's copy this container. Let's create another geometry and matrix transform. Dive inside and paste it. Okay, do we have normals in this? Okay, let's use a facet and post compute the normals. Now we have point normals. So for the matrix transformation, we're going to use a point VOP, and we are going to use 1 point. So let's use a blast, 0.0, let's point, delete non selected. There it is. So here in point VOP, so we have only the normals. So let's start from the normals and let's normalize them. Normalize means that they become unit length 1. And I have created some visualizers x, y, and z. So let's create a constant, and this is a vector, and we call it up. So this is a temporary vector, that means it's up. And we can visualize it with bind export, and this will be the y. There it is. Let's see the normal, yeah. And they have to be orthogonal, so the angle has to be 90 degrees, and of course it's not. So let's create another vector that is perpendicular to the two planes created by these two vectors, and let's do it with a cross product. So let's cross this with the y, and if we bind export it as z, okay, here it is, but we have to normalize always, so let's do that. So now we have two vectors, the y and the z. We don't need any more this. So at this point, when we have two vectors, it's easy to have the other one, because the third vector, because it's just another cross product. So we cross the z with the y, and we normalize it again. Oops. Normalize it and bind export. This is also a vector. This is the x-axis. And here it is. So, okay. We have three vectors. Let's color correct them. The z is blue, the x is red, and the y is green. What we can do with these three vectors? Well, we can create, for example, look at, and use two vectors, and this will give a matrix 3. So they will do, this VOP will do the third axis, or I like to use the vector to matrix 3 because I already have calculated the 3 axes. So this is the x-axis, this is the y-axis, and this is the z-axis. So we have a matrix 3. So this we have created now the rotation matrix. But we want a matrix 4 by 4, that is the transformation. And for that we can use a convert matrix 3 to matrix 4. And now we have a transformation matrix. Well, how we know that this, what we did, is correct? For that we can use an VOP called determinant, and we can bind export it as determinant, and this should be 1 and is -1, so something is not correct. Maybe this should be switched, and now it's 1. 1 means that it's good and there are no skew, no strange things happening. So now with this matrix we need another VOP called the translate, and we translate this position, okay, and we multiply first the rotation and then the translation, and this will export it as a 16 float 4 by 4, and let's call it, I don't know, my matrix. Okay. At this point here I'm going to do it red because this is we're going to use it also for the next example. This is now the origin. I mean, we don't need this. Here is the transformation matrix for every point, but actually we need only one point. If we if we change okay, let me see, we have the information, let's call it, this is my matrix. Okay, let's make it yellow. So let's transform now this geometry with this information. For that we're going to use another point VOP. So let's import point attribute. We need only one point, 0. This is matrix 4. We call it my matrix, and position goes to position. We always multiply with this, and if we see it, file matrix 4, my matrix file, this is the second input, he jumps up because we have to invert the transformation. And look now, he snaps in the origin, and that point that we deleted, it's now the center, this one. I can choose another point. Let me see, point number, oops, not this, let's say 8845. So 8845. Look now, that is the center. this is the center of the... Okay. So apply with Y matrix. Sorry, this is invert transformation. And let's do it like this. So now here we can... Okay, we have still the shading, the normals moving, but we can ignore that. So now time dependent, yes. So time shifted. The same thing that we did the other in the other example. Time shifted as offset 50, scatter a few points, 20, Voronoi fracture. So this one with this one. I don't know, I think I have... yes. So, okay, we transform it. Now let's apply the animation. And we can do it, we can copy this inverted transformation. So we say, we're using the same matrix. We want this object, this animation. We want to take out this because we don't want to invert it. We want to apply the animation. And here it is. Maybe a facet. Post compute. And it's very fast. So yeah, this is good. Let's do the third example that maybe will explain better why this is the origin. So let's object merge. Another model I found on internet is a hat, a free model. And it's not moving, it's just standing there. So if we see here, I can transform it. Let's move it like this. Let's rotate it a little bit. It's not a good hat. Like this. Maybe rotate it, move it down. Okay, good enough. So we can take this VOP and apply the transformation without the inversion. Let's merge it. This one with this one. Let's apply color and facet. Maybe we can take out these colors here. Color, let's make it yellow. Okay. Okay, so this is now, we will see that the head will follow now perfectly the animation. Okay, this is it. I hope you liked it and found it useful. Hopefully it was not so long. If you have any question or request, please let me know in the comments. For now, bye.